So, hello and welcome again to AWS 3-City Meetup dedicated to the AI technologies and the tool sets that we have in cloud and AWS in particular here. And before we start, let me introduce myself. My name is Aliaksei Semirski. I'm a senior systems engineer at EPAM. And today I walk you through through the, let's say, the warm-up theme about how we managed to build, design, and our application and what lessons we've learned. So everything started with the EPAM AI hackathon, and our team that consisted from DevOps engineers only had to choose the topic to implement. So during some discussion and with some democracy, we agreed that we will go with autistic children mood recognition application. And as you can see already, the topic was inspired by the Good Doctor series that actually shows that it's pretty hard to build the relationship with your colleagues and with people around you being an autistic person. And with that, we thought that it might be much harder for the children with an autism to deal with people around them, because as you can see on the slide, they express their emotions in a different way, and that leads to the difficulty in recognizing and interpreting the emotions of others, and it also has a huge impact on social and emotional development. And here you can see some slide with the statistics for a year 2022. As you can see, these let's say not actually the problem, but difference has huge numbers between among children. And yeah, so actually it shows that it's a real problem, but with the development of the countries and medicine, it became much easier to diagnose this autism thing. So, and our concept was to build and utilize AI technologies as much as possible, because again, we're a team of DevOps people. We have no idea how to build huge applications or applications in general. We're like aware of some coding and scripting, but yeah, so, and with that in mind, we decided to go with the service that will perform all the job for us to obtain the better results and to save our time, because we were limited in 2 weekdays, actually the Sunday and the Saturday. And also we decided to go with the OpenAI ChatGPT model, just because we can, and we had some money there. So, and the idea was to provide valuable feedback for the caregivers of those children. And here you can see our architecture. So everything works pretty simple. User upload the image to our website that was hosted on a S3 static website platform. This upload triggers the API gateway. API gateway triggers Lambda. Everything happens there inside with the Recognition API and ChatGPT API. And this thing returned the, let's say, valuable information for the caregiver. And about the architecture approach, so the main idea was to design the architectures that does not require a lot of things to manage, and we decided to go with CloudFront and S3 as a front-end part, gateway, API gateway, and Lambda as a backend part, because we wanted to adopt serverless processing, and we didn't want to manage anything to build. Well, that's much better, thank you. To build our infrastructure, and with that in mind, we designed it that way, and that allowed us to spend more money on the model training and processing the requests with API. I'm sorry, not the API, but with the Recognition API model requests. So, and few words about the Recognition service. So it's a cloud-based image video and analysis service that makes it easier to, like, actually it's out-of-the-box service that works already. You just need to create a data set of your images, label required stuff you want to recognize there, to be recognized there, and train it. So as you can see, you just need simply to draw a rectangle there, say that, put a label, and yeah, spend some time on training. And let's check what do we have for our model here. So we created a data set of 217 images, 70 images, and 30 labeled test images. And we achieved the result of 0.8 out of 1. And that's actually quite good because we didn't spend much time on it. So yeah, we got a pretty smart model for our purposes. And why did we use it? Also because we are not psychologists. We don't work with such kind of children. So we decided to go with a limited number of emotions, such as anger, confusion, annoyance, happiness, and fear. And yeah, that's helped us to build a, let's say, more or less accurate model. And it worked well. And here's some part of our next AI thing, that is ChatGPT actually. So here we decided to parse recognition API response because it was actually quite messy. So we prepared the data before this prompt and left only required parts there. And we designed this prompt. We tried a various ways to design the prompt to obtain better results. And we decided to go with a one-shot technique, as you can see, because it was actually quite accurate and fast. And we decided to go with a ChatGPT 4 model because it works well with JSON and stays in the context for a long period of time. So, and as a result, this thing provides us with a again, quite accurate result for a caregiver, how to deal with a children emotion. So, and few words about this prompt. So, again, best practices for the prompt engineering. Create a scene, define a role, define a task, provide some examples, and you have a great result there. And here's our Lambda. And I wanted to draw your attention to the API of the recognition client. So you can see here max results and mean confidence parameters. And these two are quite interesting because, as you can see here, we have annoyed and scared emotions, and scared tells that we have 58% there. But we set the minimal confidence of 0.7, that is equal to 70%. And the idea is that in case you have max results defined, minimal confidence is not counted. So in that case, it returned only 2 emotions, and only 2 emotions are shown. So we spent like, let's say, half an hour trying to figure out what's going on and what's wrong there. But this only because that way how the recognition service works. So yeah, and this is application breakdown here. Everything is pretty simple. So you just click, choose the file, upload your image, and everything processing, and you obtain the results of emotion analysis and how to deal with these emotions. Okay, so and here are some assets that were generated by AI. So we created our logo, our background there, some HTML and JavaScript piece of code here. So, and also CSS code. So every part of the front end was developed by the AI model. And we actually just updated it by saying, please fix this and that in application that we were using. So, and these are the services that we were using. So, obviously, our heart, the heart of our application, the custom labels model, Anthropic Cloud via AWS Bedrock, my journey to generate the images, and ChatGPT 4 to be a part of our application. And if you're interested in exploring the more services that AWS provides, please visit this link to get more details there. And also the learned lessons. So obviously with this small piece of code, we were able to achieve expected results, but there also were additional lessons that we learned. So the first one, obviously, is that we learned how to work with a custom label service. Again, pretty simple thing. Just put your image, create a label, train your model. And next one is pretty interesting here because we missed that part. And after the event, we noticed that for 2 days, it consumed like $150. So the recognition service actually inhales your money, and it takes for something about $4 per hour to work. So it's not designed to, in case you have money, of course, it's designed, but it's not designed in general to work with a constant workload or to be in a demand state. If you want to use this, for now, the better practice is just like to turn it on, process all the images you need, turn it off, and yeah, you will save a lot of money and will obtain results that you wanted to get. And also, again, quite obvious things here, practice in prompt engineering. So there were a few engineers that wanted to get more of the AI in general. So we spent some time learning things. And the last one, don't even try to create a Lambda layers on Apple Silicon chip for Python, because you will encounter a lot of problems there because of the platforms are different, and you'll need to. So in our case, we created a EC2 instance, put our code there, run everything we need, and finally we were able to create the deep package for the Lambda layer. And yep, that's actually it from my side. Thank you for your attention, and feel free to ask any questions. Yep.
Actually, I have. Can you hear me well?
Yes.
Okay, I have two questions. First of all, do I understand correctly that?
Can I? I give you one microphone.
Okay, good. So, as I mentioned, I have two questions. First of all, do I understand correctly that recognition was responsible for identification of emotions, right? So,
Yeah, actually, we trained our model to identify emotions. Pretty quite simple for us to interpret. Maybe not quite for. So again, it just was our. Hello? Can you see me better? Right. So yeah, actually, we designed it. We not designed it, but we trained our model to deal with emotions. So we had, let's say, the data engineer that who worked with these images. He actually spent a lot of time there. He was accurately selecting face features, labeling them, and yeah. That's,
but you were training recognition with it.
Yes.
So ChatGPT responsibility was to give advice based on
yeah,
result.
so AWS Recognition returned the huge JSON. We prepared a document for OpenAI model, and we fed it to it. And yeah, ChatGPT was responsible for providing the result in result response.
Yeah, and second question, if you had to train recognition to recognize autistic children emotion, where did you get a labeled dataset for it? Because if I understand correctly, it's very specific thing, and recognition as a service may not recognize those emotions correctly. How do you know that your solution is valid?
Yeah, that's the case. So again, by default, recognition provides you with some demos. You can use and try them, but in general, you need to train your own model. So again, our data engineer browsed through the internet. He tried to pick most relevant pictures. Again, a lot of, not quite a lot, to be honest, but there were some resources with dedicated to autistic children and autistic people in general. And yeah, we took those pictures and we were carefully labeling, again, from our perspective, because we are not psychologists, we don't work with them. We tried to be accurate as much as possible and label these images with corresponding emotions. And yeah, just from our perspective. It's like not going to be 100% accurate from perspective of those type of people in general, but we try to achieve it.
Yeah, it was mostly like a proof of concept. I just was curious whether there is some open source database of such images.
No, unfortunately, no. We had to create our own. Yeah.
Okay, thank you.
Okay, and can I ask about the parts where you used OpenAI?
Right.
Did you consider switching it to models provided by AWS by default? So I mean, whether more Mixtral or Llama models, because you can if I understood correctly, the responsibility of the second model was to interpret interpret some JSON. Okay,
Right.
so you could just prepare a fine-tuning data set and try to fine-tune using, I don't know, LoRa to make the free model perform the same task. So you save, because GPT-4 is like 10 times more expensive than 3.5. And if you use a model provided by the AWS, like Llama, you gain performance by reducing inference time as well as cost. Did you consider that?
Right. So again, it just was a part of our hackathon project, and we, to be honest, didn't think a lot about what are we going to use. We know that we have our AWS subscription, and we also wanted to put some additional AI stuff around. So we just decided that this part will go with AWS, and also we wanted to show that we will that we are able to. Actually, let me rephrase it a bit. So. We wanted to show that everyone can build an application using any technology, so on every platform. So in that way, we try to show that here is how we work with AWS Recognition service, and here's how we work with OpenAI. So actually, mostly that was the goal. So not quite about the design, but we just wanted to put things inside.
Okay, I understand. And did you try to use Assistance API from OpenAI, or you just used regular prompt?
Yeah, regular one.
Okay, regular one. Thank you so much.
Yeah, thank you too.
Thank you. Another question?
Hello. I have one that probably, since it was hackathon, it remains in the open-ended, but what would you think, or what would you advise to change in the regular QA process while working with the AI-generated everything here?
Yeah, let me think. So actually, the first of all, double check everything it provides to you. And again, in case you're working with code, double check, unit tests, integration tests, so on and so forth. Not quite from my side, I would say, because it's pretty specific. So again, if we are talking about the assets that that are code, obvious stuff. So check, commit, CI. You're done. In case of the images, so double check that it's actually best practice is working with AI. Double check that it's not ruining the authority rules and so on and so forth. That it has no, I don't know, blaming stuff. So yeah, that would be it for me.
Okay, and I can speak without. Sorry. So, and for this some space of models, yeah, because you trained it, yeah, you have a data scientist that trained it. Were there additional steps, or would there be an additional steps to check this confidence level?
So as far as I'm concerned, because we were not spending a lot of time in AWS, but from the perspective of ChatGPT, for example, because I'm more well aware of that, I would obviously interpret some things, implement some things such as, there is an API point to check stuff like about the installation, violation, rights violation, and so on and so forth. Actually, I would use that one. Also, some monitoring stuff about what type of, it's not related to our application, but in general, what type of prompts users tries to use. And yeah, it will provide a lot of details how we need to tune our model. Actually, yeah, design your system prompt correctly. It will work like in 90% of the ways, because I believe we don't use ChatGPT 3.5 so much here, and we're moving to new models, and it's much more stable in terms of system prompts. So yeah, just design your system prompts, set up a monitoring for user prompts. Yeah, follow best practices.
I saw some questions on the on front. Yeah.
What did you use Midjourney for? I didn't
Yeah,
get that part.
Midjourney was used for for these assets. So you can see our logo here. It's
I thought you generated
it's a smiling child. So actually, I thought that it was just a ball with face, but then I recognized some hairs and these red dots on the cheeks. So yes, this small face of a child and the background with the stars and space. So we wanted to highlight that everyone is a star, every child is a star. So there is no difference. Yeah, that's our goal.
Okay, thanks.
So at first you've mentioned that you've achieved some accuracy around 0.8 or something like that.
Yes. So by the end of our training, the model achieved the 0.8 result.
So what
out
was
of
your
1.
training data set in order to validate it, or like how the validation process was calculated?
So validation happens on the AWS side firstly. So when you train your model, you then obtain the report. It provides you with false positive, with the positive results and with negative results. You review the report because it actually says, for example, on the image with integer label, it's recognized, let's say, annoyance. And you just go to your data set, fix your labels a bit, providing, I don't know, maybe more training images and train it again.
Okay, so you didn't end up writing any code or anything that
Yeah,
would
it was-
validate it on your side. You
It
will
was done completely manually, so 270 images for model training. And yeah, we were validating our results with output from AWS.
Oh, okay. Thank you.
Thank you too.
Thank you. So more questions around there? No?
Just a quick question about the images itself, because I don't know if I catch it. The images of these autistic children were generated, or
No, we searched across the internet, found few sites that provide us with that image, with those images. Not actually the children, because as far as I understand, it's like pretty personal thing. There are not a lot. We don't have a lot of images with the children in general, but we have some set of images with autistic people. So yeah, we just search the internet, label them, and that's it.
okay? And then after what I understood from your response for the colleague, you solely like taken the report from AWS, so you
Right.
didn't split like your data set for training, testing, and evaluation. Just simply.
No, there were 270 images for training and 30 images for testing.
Okay,
So yeah,
I get it. Thanks.
because there is no way to like create your model without training dataset. So you teach your model by. Actually, there is it should be 80%, if I'm not mistaken, images for train and 20% images for test. So something like that. So and without that, you're just not allowed to create a model.
Okay, thanks.
We have any more questions? I go to the front. Any more questions? No. So thank you very much for the
Yeah.
presentation.
Thank you. Thank you for your questions and we have 3 gifts to give out.
Anton and Alex have? Okay. So feel free.
Yeah, 1 second, it's stuck. Okay, so the first one go to you, obviously. You asked quite good questions and even a tricky bit, so thank you a lot.
For you.
So the second one goes to the gentleman that asked the question first, there.
First question. Oh, okay.
And the third one goes to the person here, and because there were actually pretty interesting questions about AI in general, best practices. This man in a white shirt, yeah, great, thank you. So there were interesting questions about the AI in general, how do we implement the stuff, the prompt engineering techniques, and so on and so forth. So yeah, thank you for your questions, and thanks for your time. Appreciate it.
I think we have some time, so we begin some rest.
But yeah, thank you again, Alex, for your beautiful presentation, and we will prepare for the next speaker. Yeah.